Hi everyone. So today we are going to look after the Muller Breslau principle and its applications. Let us go to the classes. So let me take a proper cantilever. So Muller Breslau principle is mainly focused on the indeterminate structures. Indeterminate structures. So proper cantilever of span L. So you need to calculate the ILD for RB. So this is A and this is B. ILD for RB and moment at A and shear force at section X. So these are the things we need to calculate for this indeterminate structures. For this indeterminate structure, we'll follow the Muller Breslau principle and we'll find it out. See, what does the Muller Breslau states? If you want to find out any reactions or internal stress responses, you just remove that responses and apply a unit load or unit rotation wherever you want. That is the statement as per the Muller Breslau principle. So if I want to find out the reaction RB, so I need to replace this with 1. So I'm taking off the load from RB, I'm releasing the load from RB. Instead, I'm putting 1 unit load, so which will make a displacement of Y, which is B, due to unit load at B. So we are notating it as YBB. So Y deflection at B due to unit load at B. Take any section, maybe which is X. So what will be the deflection? The deflection will be Y at X due to unit load at B. So this may be designated as Y at X B. So the next, you can see I'm applying the load at section X. I'm applying the load at section X. The profile will be like this. So what will be this deflection? This deflection is Y at X due to unit load at X. This is the designation. And what this intensity will be? Y at B due to unit load at X. Now we will go for the Maxwell's Betti reciprocal theorem, which says that the deflection as the first point due to the load at second point will be equal to the deflection as the second point due to the load at the first point. So which insists that, so the deflection at, keeping this one as the first point and this one as the second point, YBB, deflection as the second point due to first point will be equal to deflection at the second point due to first point. So which will be YBX. And what does the Muller Breslau states? In case of finding out the reactions, the RBB will be equal to Y, considering this fact, YXB divided by Y of BB. Since we know that YXB is equals to YBB, you may write this equation as XB itself, YXB divided by and YBB. I'm sorry, this one is BX. These two deflections. This deflection should be equal to this deflection, that is the thing, and this load will be equal to this load. So that is the reciprocal theorem. These deflections will be similar. So this is the equation for finding out the reactions. So in case of finding out the moments, we will check it out. In case of finding out the moments, you may see, in case of finding out the moment for a cantilever beam, you need to remove the moment and you need to give the unit rotation there. So I am removing the moment. See, I am removed the moment. So it will be moment alone you should remove. You should not remove the restraints against the deflection. You need to moment alone removing and applying a unit rotation here. So on the unit rotation, you may see this is the deflected shape. So this is the moreover the ILD. So in that condition, you will be getting a deflection which is YX due to the unit rotation at A. See, this is A and this is B. And there is also a theta which is A rotation at A due to unit load at A. So therefore the moment may be written as MAA may be written as Y at X any section due to unit rotation at A divided by theta at A due to unit load at A. This is the second configuration. So this is the thing for calculating the moment. So the next we will calculate for the shear force. For shear force, it will be acting at any point at section X. So you just cut the section X. You just cut the section X. See, I've cut the section. I've cut the section X, and apply the unit shear force. So it says this one is 1 and this is 1. So what will the profile? This will be the profile and this will be the profile. So there will be deflection, say X, right? And I'm indicating this point as A, B and C. So I'm writing this as C with reference to B, and this one is Y, C with reference to A. So that is the point. And also we'll have a section. So the shear force may be written as even due to the unit section. So you will have a common section. Y of XB is the common, or XA to unit load. So we may even write it as XX divided by delta of the C. So this delta of C may be written as YCA minus YCB. This is little more tougher to understand. YCA minus YCB. But during the application of problems, it will found very easy. So these are the basic formulas for calculating the reactions, moment and shear force at any section. Thank you.